How to tell a junior developer from a senior one. Juniors get happy when their code compiles and runs on the first try. Seniors, they just get suspicious. Today we talk about software renovation. This is level 4 of software evolution and you are already on topic 3. That's the last one of the theory topics. This nice paper over there is called The Realities of Language Conversions, and it inspired actually me to go into this entire legacy business in the first place. And it collects and it lists all the things that can possibly go wrong with legacy, and by now all of these things seem very recognizable to me. But just to share it with you, because it's a solid list, and if you want to learn more, you can just read the entire paper. It's not that big and it's very readable. First of all, source code may be lost, right? So it could be that there is no source code at all. It was somewhere, but they don't know where it is. Or they outsource it and it never came back, only the compiled version came. Or they have several versions of the source code and they don't know which of the versions is in production. So one of these versions has been compiled with some version of the compiler, and now it's in the production. So even compiling all of them with all possible compilers and comparing the bytecode can be quite challenging. The documentation is usually unavailable for one reason or the other, or is just unavailable because it's outdated. So it is technically available, but you can't use it because it's useless. Right, so with Baby COBOL, the documentation is minimal, but if you complain that something is incomplete, I actually fix it right away. Right? With the language that has not been supported for decades, that's not the case. Then you have a lot of pieces of old technology that has been extended ad hoc. So when the language was designed, they were expecting certain behavior from the developers, and the developers wanted something else. So then they had to screw some things into it on top of it or on the side of it. And sometimes you do have something that works, but you don't know why it works. So looking from the code, you think that it shouldn't work, but it works. And it has worked for many years. For instance, because it was exploring some well-known bug in a compiler that has been left undocumented, but was in the folklore back then. So everybody knew it. You are quite often dealing with a language cocktail. It's not just one language, but several of them, and sometimes several notations of the same language. Interoperability of those notations among themselves, of these languages among themselves, but also how they work together with other languages and tools, that can be a challenge. Then sometimes you're also suffering from the fact that the design part has been completed way before you and it has been finished, and a lot of things are uncomfortable to you, but you cannot change them because, and there goes the list of reasons. And in general, painful details are very important there, and they are very painful, right? So some ways to deal with it, right? So I promised the topic of not just legacy, but software renovation. So what are different ways to go about a legacy system or something that is perceived to be suboptimal? People not always using the term legacy. There are at least 6 different paths, and let's go through all of them. First of all, I will define what a path is, describe pros and cons, and then give you an example of my own experience. Path number 1, rewrite it. And if you want to read the Dilbert strip, just pause the video for a moment. So that's quite often the first thing that people think. So if you are in a situation where some software system needs renovating and this is the only solution that gets discussed, then be aware that maybe you're not dealing with migration professionals. And because the crucial question here, that if it took 30 years to build, then how much time will it take to rebuild? There are pros and cons. The pro is definitely that writing something now will be much less painful and much more productive, much more efficient than back then, whenever was then, 5, 10, 40, doesn't matter, years ago. But it's still better because these tools improve literally like on a monthly basis, right? On the con side, when you are developing something, you're still biased toward the technology that you are using, and some of the ways that the system was working and the way that you still want it to work will not fit that well the technology that you have today. And then again, you need to invest in some reverse engineering of the existing system before you are re-implementing it, because otherwise you will end up with a system that works in a very subtle ways, but in a thousand subtle places it works subtly different than the original system, and then it's not a replacement, it's an alternative. And you can switch to an alternative, but that's a different expectation than when you tell people that, oh, we're just gonna rewrite that part of the system. Right? So this is possible if at least some flexibility is tolerable and is allowed by the customer. And it's very good for project parts. So for instance, when you have different parts in different languages, you can decide that some parts are so small that you will rewrite them before migration because there is no replacement compiler, or because it's too expensive, or anything. So an example from my own experience was from a company that I cannot name. I needed to analyze their portfolio, right? So what I got was a USB stick with 10,000 or so different files, about 50 million lines of code, so quite a substantial system even for legacy professionals. They had obfuscated names, so I couldn't cluster these files based on the naming convention because that was gone. That was a proof of concept, so we didn't sign the full NDA yet. And the files had no extensions because this is how they were stored in the original system. Right? So the customer says, oh, this is our COBOL code base, but I needed to investigate what kind of COBOL is it? Is it generated from somewhere? Is it written? Is it actually COBOL? Maybe there is something else. And this is again 10,000 files, right? So I can't open each of the files. Yeah, the first thing that I've done, I've chosen the random file and opened that one. And it was a COBOL copybook, right? And then that's where I understood that my task will not be that easy, because a copybook is something that will be imported with a copy statement. In Baby COBOL, you also have a copy statement, right? And it means that it's not parsable as a COBOL program on its own, right? But it still inevitably it ends up as a part of the COBOL program. Right, so eventually at some point I analyzed it all, and it was a lot of manual COBOL, even more generated COBOL from some specific 4GL, and then I realized which one was it, and there was quite a lot of PL1 code there as well that they forgot to tell us about, and there were 2 lines written in a language called CList. That's a language that even many mainframe specialists, they don't use and they don't know of its existence sometimes. And there were 2 lines. One was the executable line, and one was a comment saying, yeah, I know we usually don't use CList, but come on, this is a one-liner in this language, so this is so nice. Right? So somebody thought that it's so nice, so they wrote this one-liner. So obviously, before going any further, we had no tools whatsoever to support CList, so they had to rewrite that one line and the comment into something that we could support in order to go further. And this paper tells you about how to try to do this language identification with machine learning, which sort of works surprisingly well. The part number 2, refactor. So we've talked about refactorings in particular, but if you do have the source code, it's quite feasible in many cases to just do refactoring. And sometimes you can do massive automated refactoring. In particular, in languages like COBOL, we do things like go-to elimination or objectification. So in a good way. When you identify something that could have been an object if they were programming in a object-oriented language, and then you promote it to an object, and then you create, let's say, code in an OOP language that actually has that as a language. So as a pro, on the pro side, it's quite usually possible to automate, and there are quite a lot of these special transformation languages, which are basically DSLs for writing transformations down in some good way. The negative side is that you stay still within the same technology. In the best case, you have some little upgrade, but in general, you when you're refactoring, you're not planning to change the compiler or the IDE or anything or the language, right? So it's often feasible, and sometimes it's also satisfactory. An example of that was for a big Polish bank called mBank, the biggest mobile bank of Poland. And we've executed some project with them. That was not the only project that we've had with them, but one particular project described in this paper was about part of the code base that had 37,000 of go-to statements. And we were capable of removing 99 of them with automated refactorings, which meant something like 200 go-tos remained. And that means that the quality of the code that we outputted was sufficient for them to continue refactoring on their own. So the remaining 200 were looked at manually by the experienced developers, the senior developers of that company. And then, since we've done this project with a focus on quality upfront with some testing and so forth, we were able to keep the developers happy, to keep the analysts happy, and to keep the owners happy because their code base got better. The part number 3, I call it dethrone. It's basically refactoring, but then, so you have this 4th generation language. From that, you usually generate a 3rd generation language text that gets compiled further. So instead of keeping that pipeline, you run it for the last time, you retire, you forget that you ever had this 4th generation language. The code is usually horrible, but you can then refactor it and then improve it. Right, so then you can fully automate it. You can then retire an entire language, which is a very good thing. And then you don't risk changing the semantics. Because if you're re-implementing the original 4GL, then maybe you will end up doing some guesses about how certain things work. But if that compiled to, let's say, COBOL code, then this is the COBOL code that was running on your system, right? So there is no error there because this is literally the code you've been deploying. And then if you're doing only refactorings on that COBOL, refactorings preserve behavior. So then you're also keeping the behavior there. On the con side, on the negative side, it's usually per language. So you are dealing with only one language, and it's very hard to generalize across different ones. And then, of course, you must have a very good tool set that supports all that. So some transformation language where you are capable of expressing these mappings and testing them and so forth. So this is used to kill one 4th generation language at a time. An example that we've been doing with Packbase at Raincode. This is all Raincode code. Yeah, you can pause the video to read through the text. On your left, you have the B4 codes that was generated by Packbase. It's COBOL. You can read it because it's almost like baby COBOL. And on the right of you, which is closer to me, you have the transformed code. So it's still COBOL, but it's been transformed. So while you're reading, I'll highlight some of the things there. So you have consequent paragraphs, just like in baby COBOL. You have some things some fields that you see from the logic of the code that they are expected to be already initialized once you enter this paragraph. So they are input arguments for this if you see it as a function. Then you have some actions that are performed, literally with a perform statement. On the left, you see that it's sort of a silly complaint, but it does carry some perception strain when you're trying to read that code is that there is no formatting, there is no visual structure of the code, but there are still 3 levels of nesting. So when you're reading it, you will probably, while you're comprehending it, you will be formatting it, or at least you will use sort of your fingers and say, okay, yeah, well, it starts here, it ends here? No, it ends here. Right? And it's much easier, of course, when it has been automatically analyzed and then refactor it in such a way that you have, first of all, only one level of indentation, and then that indentation is actually there. Then you have some harmful constructs that perform through. That's also a feature of Baby COBOL. And then it's replaced with just a normal perform, so the out-of-line perform. And then we have code duplication. So on the left, again, you have if, and then something, and then else if, something, and that something and something is the same. So we can collapse these two and just make a composite condition, which is easier to read because it's in one place rather than it's scattered all over different places, and you don't have duplication, so fixing is also easier after that. Boilerplate is removed, bad names are replaced with good names, and so forth, right? So this is an example of a pack-based migration, something that Raincode has been doing for 20 years or so. If you want to know more, there was a link to a paper that describes the entire process. The part number 4 is migration. Right? So you change the language, really. You depart from, let's say, COBOL, and you go to some completely different language. The realistic way to do that is to have your original program and then restructure it a bit in the upfront so that it's prepared for the change. Then you do what's called the syntax swap. Right, so you take an if and you replace it with an if. You take a print, display, and you replace it with system out print line and so forth. Right, so you are just changing the syntax of the language without doing a lot with the structure. And then you get a target program which might be structured the same way as the original program was structured. And if you're migrating from COBOL to Java, then it's not necessarily that the logical way to split your program in COBOL would be the same as the logical way to split it into classes of Java, right? So then maybe you need to do some restructuring on the other side. So this sounds actually perfect, right? You even have a plan for how to do this, but it covers several steps that are highly non-trivial, right? So the restructuring of the original is a highly non-trivial task, and you need to perform it well in order to prepare for migration. The syntax swap must be feasible. So if the languages are very different in their expressive power, then you will not be able to do that. And then sometimes you just have to map some constructs that were very native in the original language into some constructs that just don't have any analog in the target language. And then you need to simulate it, and then you end up doing calls to some library that look horrible and very hard to understand. So in specific circumstances that can be feasible. So usually in the industry we were doing proofs of concept for this. So we reach some level of understanding with the company, and then we literally take a couple of programs that they have and go through this, and then sit together and see what happens. So I'm putting back the example from mBank because I actually didn't tell you the entire story. The entire story was that we were migrating from the language that I think I'm not allowed to tell you the name of the language, but some language, some 4GL, and they didn't want to go to COBOL, they wanted to go to C#. So we've implemented some of the transformations that prepared that transition, and they already had some quite nice coding traditions in the original code base that they had. And then as a result, we produced quality C# code, which they then manually continued to refactor. Right? And that's the entire story of the project. If you want to know more, read this paper. It's it's very short, but it's concise, and it explains the story in a nice level of detail. The path number 5 is to upgrade. So basically you keep the language, you keep all the rest, but you change the platform, you change the ecosystem where this all operates. For instance, you go from mainframe to .NET or to JVM or to something that's comfortable and has all the tools and so forth. So the positive side is definitely for the customers that they don't need to change the code. Right? So, because any change, any evolution, any adjustment is a possible risk. Right? And then, so it executes in the new environment, which is very good. And it also empowers later change, right? When you are already in something like Eclipse or Visual Studio, which has tests integrated, right? Then you can work harder on your test suite because you immediately see live feedback on things. If you can differentially test it with with a different piece of code, that will speed up replacement of outdated components and so forth. On the negative side, your dependencies still remain there, and it's actually hard to design and make these solutions. So these are different products that you need, and well, as a conclusion, you can build a business on this. And one of the examples of the tools that I was co-developing was an assembler compiler, which is described in these two papers. And in many cases, we've been seeing some customers that had a lot of COBOL code and PL1 and whatnot, but they also had a very little piece of assembler code, right? So usually that was a showstopper. We would tell them that they need to rewrite, so to take the path number 1 and rewrite it before we go on. But at some point, we just sat down and developed an assembler compiler. So it contains like 1,500 pages of documentation that I had to read. There were other pieces of documentation that were luckily somebody else's headache. And it's around 1,000 different instructions with like self-modifying code because it's an assembler, right? It was a macro assembler, so a very powerful macro language that was used in a very perverse ways. The design of the language was non-orthogonal, but with some model-driven engineering, we were able to build this. And we've also had a separate project where we analyzed it for performance and also made some justifications and improvements on that. And as a result, just when it hit the market in 2016, we got a top performer award in mainframe migration from Microsoft, which was nice. And the last path and the most complex one is, I call it reinvent. When you basically take the language, you understand everything that there is to understand about it, and you redevelop a compiler. In some cases, you can cover a language subset. It's based on the customer. So if you are oriented first at one customer, and at first usually there is only one, then you need to cover only that subset that customer is interested in. So code mostly stays the same. You get modern development and execution environments, which is always a positive thing. And you get full control over the target environment, right? You are literally developing a compiler from scratch. So whatever you want, whatever feature you want, whatever way of deployment you want, whatever integration you want, it's there. It's a requirement for a system that has not been built yet. So you can express quite a lot of demands for that. On the negative side, sometimes documentation doesn't exist. So for that compiler, it existed, but I wasn't legally allowed to read the documentation. And in general, this is a substantial effort. So it took us more than a year to get to anywhere where they could even start dreaming about putting it in production. Right, so in general, this is a perfect way for a combination of a rich client, a rich owner of the code base of the legacy system, and an expert migration company that really knows what they're doing and can offer a lot of support and provide a lot of expertise there, right? So only when these two sides meet, this is then becoming a perfect path. So an example is this language that I was the team lead for the project. So Tiala was a replacement for 4GL called App Builder. This is a paper that explains one of these things. This is, I won't talk about the entire language because then it can go on forever. But this is an example of one of the notations that was used in a language. Right? It's a position based, so it's pretty much Excel but in ASCII. Right? The thing here is that if I even tried to use something like Antler, I could hammer Antler into understanding this notation by writing the grammar, but that would mean that none of the good stuff that Antler was giving me I would be able to use. And I would be fighting to make it work, and also I will be I will be sacrificing something on my side, because if I go with Enter, what does it do with the input? It scans it, right? So in any case, this cannot be faster than linear, because it literally goes through each of the characters and does something with the character. Right? And I had something like 4 gigabytes of this that needed to be parsed every time you would compile anything, because all the data structures were saved in this format. All the code was separately stored, but all the data was here. So I didn't know what kind of data is stored where, and all the data structures were accessible from all over the place. So I needed to have all of it. When you already have this it's called a pattern language, then when you have the line and you know that you need that particular part, then you don't need to scan the rest. Then you are accessing it in constant time, which is faster than the linear time. So I had to write even a specific parser generator for only for this project that would use it to construct the parser. So to conclude, renovation is not easy, and it has never been. It is a big part of software engineering, and it contains a lot of dark corners that I even haven't touched up yet in this course. But there are different ways to go about it, to do something with the legacy system, and those are rewrite, so literally throw it away and rewrite it from scratch. Refactor, so keep it, but then change some stuff locally here and then there, and then in all kinds of other places, and slowly lead it towards a better state. Dethrone fourth generation language, where you throw it away with all its tools, and then you go one abstraction level lower, but then you use other things like refactor to make it tolerable. Then you can migrate to a different language, which implies a lot of changes. Then you can upgrade the language or the ecosystem where you are without changing the language. And finally, you can retire the entire thing and replace it with some replacement if you have one, or if you have enough money to develop one, enough resources. Each way has its positives and negatives, and the best decision usually depends on the context. That's why companies like Raincode will always be in business, because they need to be there. You cannot just take their tools and apply it ad hoc. You need to understand what's going on, and for each project you need to have a closer look at what is exactly the situation there, because it will not work if you migrate all the code but you forgot about the data, and the data was stored on the database that's only accessible from the old system but not from the new one. Then you're screwed. So in order not to fail in such migration projects and renovation projects in general, you need to have a very close look into all the details, and these details can be painful. So good luck on avoiding that in your future life as a software engineer. If you have any questions, you know where to find me. See you.